Hi, I'm Kieren.
And I'm Riku.
And welcome to Artificially Ever After. For today's episode,
can AI help save the planet?
Okay, welcome back everyone.
Thanks for tuning in.
So, interesting title today. We are fully aware the irony is not lost on us about whether AI can help save the planet, because we see countless headlines today about how AI is harming the environment and potentially the planet. So we've also got episodes on those type of topics around AI drink all the water and its energy use, and it's a very important conversation and discussion to have still. So we recommend you kind of listen to that side of the story. But today we're asking a very interesting question about the flip side of that, about whether some forms of AI can actually help save the planet in certain ways. So you may ask though, to begin with, what about the planet actually needs saving? Riku?
Yes, I have a really concerning statistic from a very well-renowned Harvard biologist, Edward Wilson, who estimates about 30,000 species every year are being driven to extinction.
30,000?
Yeah.
Wow.
And the estimate's really hard to
crazy.
say, but other sources are like between 10,000 to 100,000.
Okay, wow. So it might even be an underestimate.
Yeah, Wilson's one's kind of in the middle. That's 3
my
species every hour. So
wow.
And this is also like an unparalleled rate of extinction in history. So
it kind of also just gives you a hint, which I often think we don't really think about or gloss over, like how much biodiversity there is or kind of was, like in all the total species. Do we know that number?
Yeah, so when I looked this up, it's actually surprisingly fewer than I thought there would be. So
really?
It's about 1.2 to 2 million known species, and there's an estimate that is up to 9 million total species.
Wow.
But just to put this into maybe more familiar terms to see how diverse the world really is, there's this study actually of just 19 trees in Panama, and they found 1,200 just beetle species in these 19 trees.
Wow.
And 960 of them were new ones. So
crazy.
There's this kind of poetic quote about how scientists have a better understanding of how many stars there are in the galaxy than how many species are on Earth. So,
wow.
Yeah.
And we're going to get into this much more in depth shortly, aren't we? But this is kind of hinting at where AI might actually be helping here, is understanding the picture of what's going on and how many species there are, how many we're potentially losing as well, where they all are. So it's this idea of, really understanding the problem so that we can solve it in the best way. But yeah, we won't disclose too much yet. And yeah, I mean, I'm sure it to some extent goes without saying, I feel like we do inherently know this to a degree, even though we may not admit it, but this biodiversity is crucial and important for the survival of all species and life on Earth, really, that there's this amazing and very delicate balance and kind of dance that goes on between different species within ecosystems that keeps them all working together in harmony. I think like a food chain is a easiest to understand example of that, but it's also far more complex in terms of sustaining of that particular environment. Like you have death of animals and creatures that goes into the environment and the ecosystem that then can benefit generations that come after. So it's all this constant kind of circle of life, so to speak. Sorry to use the cliche term there, but this biodiversity is absolutely crucial and key. And I think there's been this very clear trend with human history and specifically urbanization, where we've built our own ecosystems with technology that are very detracted from the natural world and environment and other species, that we to some extent feel as though we can be immune to the rest of the world and all of that biodiversity. But as we know, with the kind of health of our oceans, or I should say the declining health of our oceans as an example, we now know that what happens with other species elsewhere on the planet directly comes back to affect us and our climate that we all share and we all live in. So this biodiversity is so crucial, and it's so precious to protect. And you just look at how many millions and billions of years it's taken to actually get to this point, to have all this biodiversity and the complexity of all of life on Earth. It's something that once gone is almost impossible to get back, basically, especially in our lifetime. So it's should be the most precious thing that we look to protect here on Earth.
More on that later. And
yeah,
you might be asking, well, how are we going to bring this technology like AI technology from this detached world back into nature? And we do just want to straight away address that the AI we're talking about today that can help save a planet is actually not these public-facing, huge, large language models that everyone's so very much aware of their negative impact on the environment.
Yeah.
We're talking more about AI methods that are more providing like very fast automated analysis of like large data sets. And these things can run on your mobile phone. Like they're really not very energy consuming.
Yeah, it's almost negligible compared to like our energy consumption elsewhere, right? Yeah.
And in today's episode, we'll actually look into whether this, even if these little models are actually worth the energy that they use. But and just as a case study for how these little AI models can be so useful in the real world is in South Africa's Kruger National Park. And this is like a huge reserve, like 20,000 square kilometers.
Wow.
Imagine trying to walk around all that.
Yeah.
And basically it houses a very significant proportion of the global rhino population. And in 2007, there were like 13 rhinos that were poached.
Okay.
But within 7 years, that figure actually went up by 90 times. So there was 1,200 rhinos that were poached. And basically, traditional methods to like combat poachers was to set up these cameras with like a little SD card, and maybe
like
you hear an incident.
You try and
you have to walk around this huge reserve and pick up the SD card and analyze it.
Okay.
But now with
and then the idea is to see if you can spot the poachers and their behavior, and then track them in those specific regions.
Imagine going through like hours of video, but now with AI models, you can automatically like have the video be analyzed in real time, be connected to it, so it can detect whether there are some like poachers around and react much faster.
Okay, makes sense. But this is just one sort of piece of the puzzle, isn't it? And one's kind of quite specific application. But as we'll see today, the use of AI in conservation and in helping biodiversity and the planet is far broader, isn't it? And to do that, because it's a pretty monumental task to discuss, we have a very special guest coming on the podcast today, who is Tilo Burghardt, who is a professor of computer science and animal biometrics at the University of Bristol, where we do our own research. But they are a world-renowned researcher in this field. So his career has contributed to actually establishing animal biometrics, which we'll come on to define shortly, as this new and its own kind of cross-discipline at the intersection between computer science and biological sciences. So he was kind of fundamental in that and has led a lot of the establishing research that has contributed to some of the things Riku was just mentioning. So he was one of the first researchers to actually monitor individual animals within their natural habitat via these kind of automated real-time computer vision AI methods in the early 2000s. And that's, since then been so commonly used and has kind of become the standard within the field. But yeah, he's done so much scientific work over more than 20 years with over 100 publications that have contributed to the fields of ecology, conservation, healthcare, animal husbandry, which was a new term I come across, which is just raising and looking after animals, and smart ethical farming. So these are all the kind of areas in which these types of AI applications can help. And yeah, he's going to tell us all about it in this episode today. So shall we get into it?
Let's do it.
Just to tee us off then, if you would please be able to introduce yourself to us and our audience and just tell us what exactly it is that you do and a little bit of background about your history and how you've actually ended up in this role that you are now in.
I'm Tilo Burghardt. I'm a professor in computer science here at the University of Bristol. I'm here for quite a long time. I came to the United Kingdom from Germany in 2002.
Okay.
So we're counting 2 decades up. And I first came here as an Erasmus student. And then I studied here for a master's and then a PhD. And I really kind of had Bristol as some special place in the world because it is, and it is particularly for wildlife, because we always have the natural history unit here in Bristol for the BBC, which is kind of an anchor for wildlife content internationally. And I think now about every third-ish production in wildlife documentaries touches on Bristol at some point. So it's really on the map. And that came together with the fact that I discovered that in Bristol we had a really interesting computer vision group at the time already, which was headed by Barry Thomas, He was former NASA engineer.
Wow.
And was, in my eyes, always ahead of the days. He, already in the 90s thought of jackets that people could wear who were maybe visually impaired and could use a camera in the jacket to translate what the camera sees into sound that they could perceive. So it was, to me, this was kind of very edgy. And
very ahead of its time. Yeah.
Exactly, ahead of its time in the 2000s. So that attracted me, and then I started a PhD here in Bristol with Barry Thomas. Unfortunately, and that's a rather tragic turn, Barry died in the first year of my PhD of some tragedy for everyone, the department, the family. And so I then had a reassignment of supervisor and worked with Neil Campbell and some other people from physics here, Peter Barham and Ines Cuttle, who was a biologist. You can see that very early on this was a rather interdisciplinary journey. It wasn't purely a computer science journey that I went on. And whilst I studied media computing in Germany for my undergraduate at Dresden University of Technology, I was, from the beginning on, really amazed by what media, together with, I would say, the computational powers that arose around this revolution of having an internet available, having a cloud infrastructure available, would bring to. And whilst in my very first lecture in Dresden, I had a guy telling us about the DVD, which was the big tech of the 90s, but learned a lot really about what media really is, and that the content of media and the semantics are actually linked to the bits that actually represent it. Anyway, so to just cut the whole thing short, then I did my PhD here, and I was always interested in linking computing with media, but I was always interested in nature. Okay. And that kind of triple, if you want, is what I really went for, and what to the day excites me, is trying to utilize AI, apply it in the most complex scenarios, and that is the wild, the jungle, underwater, environments which are usually inaccessible to us, and utilize it there to help understand nature, biology, life in particular. So that was from the beginning the core of what I wanted to do. Even as a little child, I was part of I'm from East Germany originally, so we had some group of the small nature savers, kids that go out and say, oh, that's a red kite there, and nice. And just getting connected to nature in a way. So I always carried that with me from very early age.
So that thread's always been there.
That thread's always been there, and it's there to the day. And it's, to me, the real reason why we as people still engage, as children particularly, with the natural world, when a child and an animal kind of can link in the level that we can, and it doesn't need 20 years of education to do that. There's a shared emotion that links us as life, and that shows that we are part of this, and we shouldn't separate ourselves out. And AI is maybe, in my eyes, yet not utilized, but hopefully at some point in the right way utilized way of us taking guardianship of nature in a way that does not follow the destructive path that industrialization, etc., have paved.
Okay. Well, without skipping ahead, because that's definitely going to be, I think, one of Riku's questions in a second, but you're very relatable, your path, I think, to this area that you're now in, to my journey, because I have always been interested in biology and the natural world, and I kind of maybe took a slight detour from that doing mathematics and engineering undergrads and degrees, and then found my way back to that intersection. But I'm just curious if there were any specific kind of problems or challenges within that natural world and within ecology that you always maybe had on your minds that motivated you to then actually focus on that as your area of research, or trying to find solutions to those problems? Was there anything particularly going wrong in the world, or for animals in particular, that sticks out to you? It's
actually a long list, but let's pick one or two just to drive that interface, or that interface between the world of information and computing and the world of nature and life. Yep. I was always not really happy with the fact that actually bioinformatics in the 1990s meant mainly genetics. And nobody really cared, or could care, because the technology didn't seem to be there, about the actual phenotype, the animal itself. right? So people researched the gene and DNA strings and how to sequence it and how to find patterns in genes and how to isolate them, how to link them. There was lots of research going on quite early, but there was very little research going on in terms of actually looking at what these DNA structures produce. The real animal, the real set of animals in an ecosystem, how it all works together.
Arguably what matters the most.
Arguably what the DNA is for,
Yeah,
exactly,
yeah.
what it really produces, this kind of biosphere around the world, this network of life that we are actually part of and without which we cannot exist. And that there was no link to computing for a long time. And it was in the late 90s, the first things happened then, and then, that was one of the things that drove me to, there must be a bridge. We can't just, look at genes and not the phenotype. So that was one thing. But on the other hand, it was also the rise of media and networks that happened in the late 90s that did, in my eyes, only focus on the urbanized world. So, everybody started to have a phone and then a smartphone, but that was nowhere near where nature was. The smartphones were in the cities and, maybe along the motorways, but you didn't have it. You actually went on the train, and once it would go to the countryside, your signal would go. And so there was a complete disconnect between the biosphere and what I would call the technosphere, which is our technology that we develop in nature, where it is present in its diversity and its real kind of beauty, and these two worlds have not yet connected. And possibly you could argue that with the rise of cloud centers and cloud infrastructure and these big computing giants building, these clusters of compute well outside the natural world, far out, has made that separation between compute and nature even bigger. While I would argue, actually, our only way to, not only have the negative impact of these compute centers, etc., and the energy consumption go on to the, climate change, biodiversity loss, and all of that, you need to also utilize this structure that you're building to safeguard the other side. And that is the big picture that has motivated me. And finally, to maybe that's a dream rather than something tangible yet, is the link between life and AI and computing itself. Because for a long time we thought, we humans are the, pinnacle of everything possibly in terms of our capability of rational thought and all of that. And then we're starting to discover that actually machines are pretty good at reasoning, memorizing, it's hard to compete with latest scale AI. I mean, we still have a lot of capability that AI doesn't have, but you can also see the parallels. And I think that link, trying to explain life, utilizing AI, and try to utilize similarities, analogies between living creatures and AIs in order to beneficially learn also, in the world of what you should and shouldn't do, what you can and cannot do, and how you do it. I think that is a big open question, and it leads to this final point of trying to make the biology a mathematical science in the same way like physics would claim to be a mathematical science. I can see this as a long-term aim for the sciences generally, to underpin life with the same predictive and mathematically deterministic, or at least computable structure that life is.
Yeah, I know Demis Hassabis, the CEO of DeepMind, has spoken about how in the way that mathematics is like the kind of tool for physics, that AI is potentially going to be the same for biology, which I really like that.
Yeah, and I also think that link between like AI and like consciousness is like such a big motivation for a lot of researchers in AI today. So yeah, in this episode we're asking quite the maybe an ironic question, very bold, which is, can AI help save the planet? And as someone with such a deep background and broad research in animal biometrics, ecology, conservation, what does it mean to you when someone says, how can AI help save the planet?
Currently, it's doing possibly the opposite and contributing a lot to more energy need, and currently that is often covered by more power plants that possibly fired with coal and stuff, which you may argue in the short term is not the most detrimental thing to everything, but in the long term leads us into uncharted territory, let's put it this way. So in terms of biodiversity loss and taking over land use, resource use, currently it does the opposite. But then the question is, how can there be a world in which that is not the case, and in which, like everything in the natural world, operates in balance? Right? I mean, if our energy intake and our energy outgoings are roughly balanced, then we will not only keep our weight, we will also, be productive and living well. And we need to kind of, at every level of society, get to some sort of state of balance in order to be sustainable. That would be one of the key factors today. So, and how could you use AI to make our existence in the world more sustainable? So that kind of is a guiding question for this. And the very first thing is you would want to know what's going on. So our bodies are filled with sensors that sense the environment and give us, therefore, a chance to put ourselves in the right environment for balance. In a similar way, one would need to understand the natural world first by sensing it. So the very first step I see is that with our current technology that is recordings and sensing on the visual, on the audio, even on smellscapes, and so different ways of how the senses can penetrate a habitat. One can, for the first time now, start to build a picture of how habitats or the biosphere in the large scale is evolving. And that gives you, if you want, some sort of simulation basis for what is going on, which is the starting point for making policies that can counteract. So knowing what's going on is, I think, maybe still the first core task of what AI can help. And I can give you a practical example. If you, say, want to know what is going on in a primate population in Africa, what would you do? Years ago, you would take a team, you would go to the jungle, you would take your binoculars, hopefully you would take some masks with you to not share your germs with the primates that may get them as well, and then you start counting and people that live with these animals in order to understand their behavior, etc. Build a picture of how these populations are doing, how they're evolving in terms of numbers, in terms of their needs, in terms of scale. Is the population expanding? Is it shrinking? How their population geographics happening? How they're moving? So you would do that with people in the field. And that takes enormous amounts of time and is not scalable over a whole continent, and will only give you, and that's the status where we're still today, kind of point-wise data, not global data. We're moving now into a world where sensors like camera traps, drones, satellites, sensor grids like microphone grids in the forest produce recordings of hundreds of thousands of hours, which are then viewed still to the day, often by humans. And to view 100,000 hours of footage and find the chimps in order to count them is a task which is quite hard, and which also leads to fatigue, and where, to watch nothing for several hours is not helping you to not miss anything. Let's put it this way. And and there is where the machine will, or has already found its first place, to try to process large amounts of sensor data in order to simply say what is there, what isn't, and how is this over time producing a picture of life locally, hopefully in the future globally.
Wow.
So that is the first step where AI can help just to say what is there.
Yeah.
And then the next step that I see where we're not yet at, but which we're actively working on, is the idea to try and utilize this data, not to then sit again on the desk of poor ecologists who have to work on stats frameworks, to take months of their mathematics skills to try and squeeze out a population number of the number of, say, great apes in this region has gone up by or has gone down by. Because, again, it takes an enormous amount of time to set the calculations up, push it through a framework of stats, make sure it's all right, check with other people that they have similar results corroborated, and then go through the publication cycle. And at some point, somebody a year or two after will read that a population has declined.
And imagine by that point, the actual statistics several years old.
And that's what in computer science you call stale data.
Yeah.
So the data is already way behind what's happening. In the meantime, there has been a mine built, and the population has moved, and maybe has completely declined, or maybe has risen up in a certain. So, in order to actually do conservation in a way that the data you measure, which we still don't do properly, can then feed into action that has impact and can influence how stable a population is, or what the protection status of a certain area is, or the opposite, where industry can go in and utilize resources for humans in order to make life better for the people of this area or globally. To make these decisions, you need non-stale data.
Yeah.
So, and there again, the speed and accuracy of AI as it's evolving now plays a role, and this is the current research area. And then if I go one step further, because that's now the kind of future dream, is in a way, if you have such a sensing network around the globe and integrate the colleges, the engineers, the field workers, and the people who live in habitats like, even Bristol is quite an active place, with our fox population, and so it's life is everywhere these days. It's not that urban areas are kind of out of this.
Yeah.
They're actually in. Once you have such a network, then it is a question of optimizing your response. And like our whole body, when we sense something, optimizes the response to, say, cold or to pain, you need to operate as a holistic being. And in this case, I would say we as mankind should operate as a holistic being over the biosphere in order to optimize outcomes.
Nice.
So it's not a local solution. It's a global problem, and maybe AI can bring together this data in the future in order to also have a global solution, which is at least exposing to policymakers the trade-offs that are there in a way that it's real decisions rather than guesses.
Yeah.
And that's happening today in small pockets, but a global network of that would, from the conservation point of view, be the dream.
Nice. So we're definitely interested in getting into some of those questions around what it actually enables and some of the kind of future directions. But just whilst we were on that topic and you mentioned this kind of grey tape sensing data and all this information that we now have, I saw that you'd led some amazing work which was creating this, now the world's largest, I believe, and most diverse open source data set of annotated grey tape footage in their natural habitats. Just curious if you could just give a bit of intuition to someone that's kind of maybe not familiar with kind of machine learning and computer vision, like what does this data set actually enable that we weren't able to do before in terms of these kind of ecological questions? It's not just necessarily having more hours of footage of these apes, is it? Because it's very rich annotations and has information about their behaviors, if I understand correctly.
The first thing I should say, this is an effort that cuts across disciplines. It is based on what's called the PAN-AF project, which was a project of the Max Planck Institute, but integrated a lot of research in Africa over a long time, led by people like Christoph Busch and Bjarne Kuhl over many, many, many years to try and gather footage. And then experts have annotated that footage, which with information of how many apes are there, what are they doing, even information of where it is, what's the social structure of it. So the details of a population seen through the lens of an ecologist or biologist in the field. So that is, then you have a data source, but that is only a starting point. This is like you put in front of a primary school kid, you put a lot of pictures to learn from. And what you would next do is you need to have some sort of setup to actually make this learning happen. And to the day in neural networks, which are the engines, if you want, of today's AIs, they learn by being exposed to pairs of input data, pictures or videos taken in the jungle with certain apes or behaviors happening, and expert information of the teacher, saying, that is a chimp, and that is a gorilla, and that is the chimp walking, and that is the chimp. And if you have enough of this information, like in this case, in the PANAF 20K, we have 20,000 annotated videos, then that creates a body of information with the what's known as metadata, which is the data about that footage, that can be used for training an intelligence or a neural network by stepwise, over quite some time, training a network to respond to these images in a way like an expert would, by imitating, if you want, that behavior. And if you have sufficient example representation, like in such a data set, then you can start to make inroads towards an AI that can perform well and starts to actually be able to identify, here is a chimp, here is a chimp that walks, and actually follow that instance, etc. So, and that PANAF 20K and later on also the PANAF FGBG data set. So these data sets form a foundation in which we publish the data together with all the people who gathered it and all the biologists who kind of work on it, but also expose at the same time already trained networks with baselines so that people can utilize these AIs in order to use them for conservation. And there's also a contribution for the computer science domain, if you want, to use it as a baseline for future developments. Because now you have a standard and you have a large data set. And you can almost put it out as a challenge to the world and say, look, this is where we are. We currently get so and so many % right in this. Build a better system. Here is the data, here is the testing. Everybody works on the same basis. It's proper science.
And lifts everyone up.
And it lifts everyone up. And most importantly, it lifts up because it's ethically curated data. In other words, whilst you see chimps doing actions there, the camera position, where it actually is in a reserve, etc., is not given. It's anonymized, so the poacher cannot go and utilize this data to then, use for ill-gotten gains. On the other hand, that was, I think, the reason why the PANAF 20K was an important step for primatologists, because they now have some AIs available they can use, for computer scientists because he can build on that and build new systems, which people have done and started to use it as a baseline in comparison to their own systems, but hopefully also for conservation in generally, because if you take the big picture things that the main kind of biggies, Google, Facebook, bring in, they focus mainly on the things that are in our environments, right? So
cars and
people and cars and buildings and urban environments and things where stuff's going on that is in our life, and it's right to do that. But you won't have Google Street View of the jungles of Africa. You see, and that fact that there is this, again, disconnect between the technosphere and the biosphere is the reason why we cannot utilize AI to actually do good in these areas. And that's where a data set like that, at least for a small domain and a small contribution, is a helpful thing for scientists to build on.
Right, and part of what you do in these domains is animal biometrics, right? It's a big part of your work, if I understand correctly. And could you just demystify a bit of what animal biometrics is? And also, just from a very personal point of view, I was just curious if you were to try and do animal biometrics of zebras, is that easier than doing it with horses because they have more patterns? And that kind of intuition, just for our listeners, please.
Yeah, Riku and I were having this kind of funny debate and trying to figure out, because I'd imagine because it's challenging for humans, I would imagine, even experts, to identify actual individual animals within the same species. So is that a challenge for AI as well?
It's a big challenge, and it's one of the big unsolved challenges to be able to see a particular chimp, maybe in a distance, and say who it is out of a population. This is still a widely unsolved problem.
Okay. And why do we want to solve it yet?
Well, if you knew this is chimp X, then you immediately have a step towards counting the population right. Because then you can say, the chimp I've just seen is not the chimp I've seen yesterday. If you can't say that, it may have been the same chimp, and you have doubled your population immediately by seeing one or two chimps. Right, and you can scale this now to any ecological population estimate, that individual identification is a major contributor to reliable ground information about the size of the population that doesn't rely on the statistics of appearance, but that relies on the fact that I know who's in front of the camera. Right. So that is a major driver for why individual identification is critical. But let's get back to your question, because and let's maybe motivated by what you said. Isn't a zebra easier to identify than a horse? Let's get to a practical thing. We have a research farm here in Bristol, out just towards the airport in Bristol here. And on that research farm is a dairy farm where Friesian Holstein Friesian cattle produce milk. Right, and everybody will know they have these black and white patches. And maybe everybody has thought, do they all have the same one? Of course they don't. They have different ones and actually can identify every single cow by their exact patches.
Wow.
So that's a fun thing to do, I guess, to a certain degree. And at some point you get bored. And we thought for a long time that's a good thing. And about 15 years ago now, we started to utilize that to produce systems that can identify Holstein Friesian cattle based on these black and white patches. Now, that's the first thing you look at. And then the question was, well, what if the cow is black? That is the zebra-horse similarity now in terms of cows. And a lot of the cattle in the world are black. So not every cow is a Holstein Friesian. And then what we did is we used something called time-of-flight cameras. These are cameras that, instead of just taking a picture of the world in red, green, and blue, they shine a light, so to speak, in the scene and measure how long the light took from the camera to the object and back. And by doing that, you get for every pixel, for every element of your image, a distance rather than a color.
Like a 3D photo.
It's like a LiDAR almost.
Exactly, you get what's known as a depth map.
Yeah.
Right.
It's a map of how far away is stuff from the camera. Now, if you film a cow from the top using one of these cameras, you basically get their backbone, right? A bony kind of surface of that. And surprise, surprise, this signal is as good as the black and white patches you see, and every cow is unique. And even more so, this is now applicable to black cattle. Okay. Right, so you wouldn't need, and it works in the dark because you have loads of things which you would not think about immediately when you think of identifying an individual animal. It is often looking closely at the problem and actually understanding the sensing space that leads to information that can be utilized to understand the animal, the individual, the species, the group, the behavior, etc., etc. Now, going back to what animal biometrics is, animal biometrics it's still an emerging field. It's very young. I mean, the first paper when we pinpointed this as a term is 2013. That's a decade ago or something. And it was about two things: representing and detecting the phenotype. So, like in a way, what the bioinformatics did with genes to identify, I can represent a string of DNA. I can then detect this DNA in a living being. That's what we tried to do for the phenotype, for the living being itself. And to represent it means to have a mathematical model of it. And to detect it means using this model to then, in sensing data, find it, identify it. As an individual, as a group, what is the age of that individual? Is it a male? Is it a female? Is it a juvenile? Is it a newborn? Is it to literally start to categorize the different species, individuals, groups, behaviors, morphological traits, details that matter about a living being from sensing information. Now, this can be widened a little bit into a domain that's known as imageomics, which is basically a play on genetics and images. So it tries to do the omics, the understanding, on images in order to understand biology. That's kind of a shifting animal biometrics towards the biology domain and trying to use it to understand biology via images. Or you can shift it towards the engineering domain where you basically go into life sensing. So sensing anything that lives and sensing the vitals and in the end, the very detail of it. The last thing I want to point out, when we wrote this, I wrote this in 2013 with a biology or ecology professor in Germany called Kieren and Riku, who's the first author of this paper where we laid down what animal biometrics is. And it was he's from the Max Planck Institute at the time in Leipzig, and it was a very fruitful conversation I knew very little about biology, and Jan knew much more about computing than most biologists. But just to have a conversation completely across traditional subject boundaries was so enormously fruitful. Yeah. Because you discover, on the one hand, you're actually researching very similar things with incredibly different methods, but you also have to add to what the other one does in the discipline in order to widen the scope and often produce solutions that you could not. Now, by bringing this together, just scoping what this is, and at least I believe it was a starting point for this type of engineering underpinning of biological field research first, but biology generally. And what we wrote in the paper, and I can quote here, to advance animal biometrics will require integration of methodologies among the scientific disciplines involved, and such efforts will be worthwhile because the great potential of this approach of animal biometrics rests with a formal abstraction of phenomics. That is to create tractable interfaces between the different organizational levels of life. Wow. And I think that's still the heart and the core of this discipline. It's all its guises, whether it's applied to smart farming or to conservation or to pets at home. It is still trying to formalize engineering approaches to measuring life, biometrics.
Wow. That's awesome. Yeah, thank you for clarifying that. I mean, it does feel very relatable because in my own research, I'm actually coming from a sort of genomics position. That's what my research is in. So it does feel like there's a lot of...
critically related.
Yeah, exactly.
There's a direct link also because obviously the phenotype is originating from and the other way around, the phenotype changes the genotype over time.
Yes.
So you have literally this kind of bounce back and we haven't even talked about this. Look,
the epigenetics of it.
We haven't even...
Well, I had a question that was slightly off the cuff, maybe a bit more general. I don't know if it does apply to kind of ecology in the same way, but my brain the whole time was jumping to the history of genomics and how our understanding has evolved from there, that we have always done this very bottom-up approach of, within a genome, we find the individual genes, then we try to understand their functions, then how they interact. So we work our way up. It's a very bottom-up approach through the levels of complexity of life. It seems as though something similar is going on with these sensors, that you're firstly starting off with individual animals, trying to find the same individuals, then seeing how they interact at population level and going up. My research actually is coming from a maybe less popular field within biology, that we're trying to go from a top-down perspective. So it's a systems approach where you look at all of the behaviours and try and categorise them and then meet the genome it's in the middle. I was just curious, again, largely coming from my own curiosity, is there a top-down aspect to this from ecology, from understanding, the populations and the environments at a higher level and then matching that to the individuals, or is it not as relatable in that way?
Amazing question, and I think we could fill the next day discussing that relation. And why? Because just think of what a neural network is these days. It is hundreds of layers that are mapping from very simple data to more and more complex data.
Emergent behavior.
Layer by layer by layer by layer. And the reason that networks have become deep is not that mathematics cannot use just whatever 4, 3, 2 layers to, 2 hidden layers are sufficient to model mathematical functions. Why do we have 200 or 300 in current networks? It is because of what you started to describe here. The nature of complex relations, of complex patterns, emerges as I would almost call it a semantic core, which decomposes into intermediate stages. In a similar way like our own brain processes it, in a similar way like deep neural network processes it, they reflect the state of matter or the state of information in a gene encoding in exactly that mapping. And in computer vision, the area I work in mainly, which is the side of using AI, using imagery and videos to do this, it's even clearer, because at the very beginning of it, you have pixels.
Yeah.
You have individual elements of red, green, and blue, which are similar, I guess, in a DNA string to your...
You zoom out far enough.
And then you go step by step to discover meaningful relations and combinations of these pixels that make up, in the very beginning, just things like, edges, corners, things like that. And then you build further, and you build into possibly body parts. And from the body parts, you build up into... and in the end, you may have really complex behaviors. Now, again, if you take seriously what animal biometrics should represent, then you should end up in your last layer with the most complex assignment properties that apply to whole populations. Nothing of this sort exists today at all. Instead, we're ending with, I have detected a species present somewhere in frame 19 of the video. So we're far off that. But it should be. And I think that is where I would relate to your question, in the sense that the future of truly harnessing the power of deep networks to map from pixel observations to population properties and back. Because to train these networks, you naturally would utilize properties that emerge from entire populations, or discover them using reinforcement learning, or simulate them. There are various ways of training networks, and not only by doing the imitation game. And I'm not relating to Turing of imitating an expert that has annotated the data set. Right?
It's so-called supervised learning.
Exactly.
Wow, fascinating. Yeah. I'm glad I wasn't going too much on a tangent.
No, it's a beautiful area to go into, and I think a lot of future science will be about producing these very high layers. If you think of our own visual system, how it processes it, we start with the retina, and then the nervus opticus, and then the visual cortex, VC1, VC2. So actually our own brain has a layering structure, at some point ending up with something that gives us hopefully a relatively complete view of our senses in order to make decisions, in order to summarize the world in a high-level state. And that we use to then control the world backwards in order to, go back and act in the world. And in a similar way, neural networks, hopefully in the future, can do this for both the genetics as well as the phenotype domain.
That's also our North Star within genomics.
That's
as
right.
well. But just one quick last one then before I know Riku is definitely chomping at the bit to ask some of the kind of ethical questions, but just a quick one then, in terms of getting to that vision and kind of where we are now in the world of kind of animal biometrics and trying to get to that point in the future. I saw that you were one of the first researchers to actually monitor individuals and animals within their natural environments using these technologies like camera traps and these video devices. I'd imagine this is much more common now within the field, and as technology's advanced and it's cheaper to use them. So, is data and gathering all of the kind of video footage and understanding of these species, is that still the bottleneck, or are we starting to see the bottleneck shift to actually kind of turning that data into meaningful insights and then even actioning that data? Is the bottleneck starting to shift further down the line?
It is starting to shift. But the biggest problem is still to get the data,
right,
because of the disconnect between biosphere and technosphere. So if we would have the same density of cameras that we have on the city of London in the jungle of Africa, then the problem would be solved.
Right.
But we're not there. So let me go back just very briefly on this, because over the last 25 years, a massive jump has occurred, and I think it's important for your listenership to appreciate that. When I started to work on this in the very early 2000s, 2004, something like that, going into the wild to film penguins, African penguins at the time, on Robben Island, etc. We had cameras that cost £2,000 a camera. That was, it wasn't a mobile phone that has 4 times, 10 times the resolution of that. We used an Ethernet cable to run for 200 meters with, support things that were chewed up by possibly rats or So that was and then sitting somewhere in the middle of Guano on a table with 2 laptops to try in real time process these animals walking by that camera. That's where we come from,
Not
right?
going to scale that, is it?
And it only worked in situations that were really well behaved, good data, and obviously definitely not, rain and fog and all of that. And we've come enormous ways. So species detection is well possible in relatively degraded data today. Camera traps are cheap.
Yeah.
You get them for a 2-digit amount of money rather than 4-digit.
Yeah.
And it is possible to enormously expand on the quantity of these now. You have grids of hundreds of these being put in the field in order to get an overview not of one point, but an area over space and time, which obviously produces much more reliable data. And then finally, I would say, it is also the transmission technology that has massively changed. There is no Ethernet cables lying about. People use 5G here at that point where I'm sitting.
We've got satellites now as well. We can probably tap into soon. Starlink.
That's it. And actually, we do. On the Wild Drone project, that's a project that's happening here. Starlink is used in order to link us up in remote positions. Like our mission in Kenya there, to get internet access to places. And to be honest, I don't think it was really, Starlink's mission from the beginning on to, support the biosphere of the world. But there may be a side effect here of by providing internet access to remote places, you don't only help humans, but you help also the related life infrastructure there, if you want, the ecosystems, habitats that these people live in order to link that information up. And you can imagine that in the end, that infrastructure may be the driver for that dream of global interconnection and understanding that is not stale data, that is data that is live or close to life, at least live enough to act.
Wow.
Amazing. Hello, Kieren here to interrupt the discussion, but we thought it would be nice to take a little fun fact break before we continue the conversation with Tilo. So, Riku, do you want to tee us off?
So I've got a fun fact that surprisingly links croissants to cancer cells. Or detecting cancer cells, probably what I should say, sorry. But in 2007, there was this Japanese computer engineer called Hisashi Kanbe, right? And he actually was working with this bakery because they had this problem where you can't really put a barcode on a fresh baked good, right?
Yeah.
So back in 2007, they already built this computer vision software to automatically recognize what baked good you have.
Cool.
And they called it bakery scan.
Like a self-checkout type thing.
Yeah, kind of like what I think now it's quite common, but 2007, man, that's pretty ahead of time. And basically, many years later, this doctor in hospital in Kyoto actually just saw in the news bakery scan and how it worked by basically analyzing the texture of the pastry and drawing these little boxes and things to help identify it. And he had this realization. He was like, well, under a microscope, these cancer cells actually look quite similar to these little bread
flaky pastries.
Yeah, flaky pastries. So
crazy.
Yeah, the doctor reached out to the company, and together they actually repurposed the same technology, trained on cancer cells, and it ended up with this system called I don't know how to say it, Cyto AI scan.
Okay.
And basically, it got a 99% accuracy rate over the detecting cancer cells.
Very cool.
Basically, the message here is the same underlying AI technology can really kind of solve the same problem in many different, completely seemingly unrelated fields. Yeah,
very cool. Very unrelated, aren't they? But there you go. Nice. Cool. Well, I'm glad yours was quite a fun fact, because mine is just more of a fact. Maybe not so fun AI facts this time, but I definitely need to stop picking kind of bleak AI facts. But this one's quite important, I think. But basically, last summer, there was a 50-year-old grandmother from Tennessee in the United States of America named Angela Lips, and she was arrested at her home and told that there was a warrant out for her arrest in Fargo, which is in North Dakota, which is over 1,000 miles away from where she lived, for a bunch of bank fraud cases.
Oh dear.
But the problem was she'd never even set foot in North Dakota in her life. But she ended up sitting in jail for more than 5 months including getting on a plane for the first time in her life so that she could be extradited to the state. But it turns out that it wasn't her. She hadn't committed this crime, but a neighbouring police department from Fargo, which was in West Fargo, had basically bought themselves this Clearview AI facial recognition system. And this company, basically, they use like billions of photos scraped from the web. I think they've been targeted for like copyright claims before. And social media as well to perform like facial recognition. And they ran a photo from a fake ID that was used in this fraud case through this Clearview software. And it gave Angela as a potential suspect based on similar features. And they then passed it on to the neighbouring police institution, who basically didn't check it and they just ran with it. And arrested her, but the Fargo police chief later admitted that his own department didn't even know that this neighbouring agency was using this AI facial recognition software. And they said that they would never have allowed it if they did know. But yeah, Angela spent Christmas Eve getting released from jail after her own defence lawyer pulled bank records in about 5 minutes that basically proved she wasn't in Tennessee the entire time. So the police could have quite easily done this. And yeah, the bigger and like super scary part, which was in this article I read, which was basically that a criminology professor pointed out that police forces across the US are increasingly adopting these AI tools faster and faster than anyone can actually evaluate whether they work correctly. But the scary part isn't necessarily the pure tech failures of the AI. It's these like tech plus human failures where like it's increasingly happening that like police officers and in other domains, they're taking the outputs from AI systems and not thoroughly checking them and just like rolling with it. And this is what can happen if we do that. So
that's really scary.
A bit of a scary fact.
Yeah,
Maybe not a fun fact, but an important one nonetheless, I think.
I'm glad Tilo's one's a little bit more lighthearted.
Yeah, over to Tilo for his fun fact.
Okay, Luke the Nuke has or wants to patent his face.
Okay.
So he's a darts player, one really kind of cool sports personality, but I think this went through the BBC recently, and thought, oh my God, what does darts have to do with AI?
It's not Luke Littler, no.
It is.
Yeah,
it is Luke Littler, exactly. So
wow.
Anyway, it's a fun side fact that the fact that Gen AI etc. enables so many things, and that there's an open discussion point currently. How far should you go? Should you be able to? In Denmark, there have been laws now that your voice, your face, they are yours, and you own them.
Likeness,
and how do you own that? And if you think about the whole community in Hollywood and in filmmaking, in acting, and what is ownership? Do you have ownership of your own tokens, etc.? That's basically what I want to point out. That it's an interesting time where currently the law is shaping around this, and it's in its very embryonic stages, but it's an important one because it will, in a way, tell us what our society will be like in the future. What is ownership? Do you have ownership of hopefully your own body, but maybe your own token of the face?
Your voice,
your voice,
Crazy.
These are big questions, and I think whilst it is a fun fact that Luke Littler and the copywriting of his face is, on the other hand, it's also an important moment in time to think about. What will that be in the future, right? I mean, the invention of property and that we can own things, etc., is the major foundation of a lot of what we do in terms of our economy, right? And then what do we do with the virtualized aspects of that? And I think we're very beginning there. And then you can ask the final question, what role does nature play in all of this? Does nature have a token we can copyright, or I don't know. So anyway, that's a fun fact for me, and it opens the door a little bit into what's very important at the moment, and where people should start thinking how a society should deal with this.
We love a fun and slightly dystopian fun fact at the same time. Brilliant, thank you.
Well, thank you, Tilo, for joining in on our fun fact segment, and back to the episode. So just to, be the I don't know, devil's advocate maybe, but just to link these two last points, because it's really interesting, and just going into the complexity of how these deep neural networks are. It's quite unintuitive to know what they've learned, and I think for our listeners as well who've gone on ChatGPT and use these chatbots, like it happens less now, these things with hallucinations where they lie to you. And there's this idea that, okay, well, can I trust the AI system? How reliable are they? And in this space of conservation where there are very high stakes, right? We're talking about some species going extinct, and that's a big reason to monitor them, right? From what I understand. So how do you balance when to use AI or not? And maybe how do you reassure people that we're actually using AI for good in this landscape?
Okay, I should lay down my cards from the beginning. For the last 5 years or so, I do not use any AI on human data because of ethical concerns. And then you may immediately ask what you're asking now, but why are you using it for animal biometrics? And my answer to that is actually straightforward. Because the problem is so big. In other words, we know so little of what is going on in the natural world that the damage that can be done is orders of magnitude smaller than the damage that is done. And so from my very limited, subjective, humble point of view, I do see this as a AI for good challenge, since the downside of it, of not using it, is business as usual, and complaining about that biodiversity is shrinking whilst sitting on using your phone is exactly what we should not do. So the worst case scenarios we should counteract as strongly as we can, and this is anonymization of localization, not giving poachers ideas to where to find animals that are on the red list and all that. That is the baseline, and all scientists and practitioners should adhere to it. That's the core. But beyond that, I think the potential for damage in this domain is smaller than the potential of damage in almost any other application domain of AI. In the sense that, yes, you may misidentify an individual animal, maybe you get a little bit skewed population numbers, but then again, you get skewed population numbers by not utilizing that data. And therefore having no evidence whatsoever. So it is more about I would say, guardianship of the data along the way. And having responsible mechanisms to identify biases and problems along the way, like in any AI domain, that will help us, or is helping us, to spec it. Now, linking back to, okay, ChatGPT is lying to you. Is that a big problem if you apply it in the conservation domain? It is, but the difference is a rather technical one, in the sense that if you ask a prompt to ChatGPT, you're allowed to ask quite a lot. It's a very big space of potential sentences you could ask ChatGPT. Whilst the tasks we ask are not that broad. To find a chimp is a very, very, very specific task. And the biggest problem I see for AIs today is to react to unseen data environments. In order to operate well, you need to operate in a domain where you have seen data, where the machine during training has been exposed to signals which are similar. And that diversity is much smaller in the conservation domain than it is in a general setting, like a prompt where you can put any text to ask the AI. So therefore, the rails for the AI are naturally much more narrow, guarded, and specific. So in a way, most systems today for animal biometrics are expert systems that work on one specific thing. And animals are not trying to fool us. They're not, putting disguise masks on to not be chimp number 5 today, but they're chimp number 6.
Horse painting stripes on its side.
Exactly. But humans would do that all the time, right? I mean, and that level is really showing you where the difference sits and why animal biometrics is a good domain for applying it for good. Because the limits of benign behavior versus ill-gotten behavior are different to the ones when you have a general system which you expose to the general public. So it's a specific, very guardrailed system where one can take care almost under lab conditions when you train these things, because they're expert systems for very, very specific tasks. And as long as you have sufficient data sets like the PANAF 20K data set, which expose a large variety of real natural scenarios, then unless you're trying to find a chimp in a shopping mall. And by the way, there was an interesting thing. I think a wolf in Germany walked into Hamburg at some point. And then obviously we are not prepared for this. And it was a tragedy that happened there. But the whole point I want to make is that as long as you apply this in the right setting with the right learning settings,
You can have some confidence.
you can have more confidence, and you have less chance of truly disastrous operation. And then you just spec your bounds, and you should know where the limits of AI sit. But that is in the hand of the users of it, the ecologists. They're not the general public at the moment. So therefore, hopefully, the abuse, if any, would come from humans and not from the environment where it is run as an AI.
And just one more, whilst I can be the anti-AI person in the room. But so I think that was really really helpful to understand that kind of you have an expert AI system which has a much more restricted set of outputs that is very different to ChatGPT, which kind of can tell you a bedtime story and also, I don't know, tell you to make a bomb. So that was really clear. And one other concern that people have, again, I think there's this general idea that everything AI is a chatbot, and we're really keen on this podcast to really demystify and break that assumption, because AI is so much more broad. But nonetheless, so people are very concerned about the energy consumption and the environmental impacts of the AI itself, And just curious if you can comment a bit on, are these camera traps, they use a lot of energy, maybe these drones, and the ways we are sensing the environment to use the models or train the models. How do we need to worry about that as the general public?
We do. And I think this is a growing problem. It's not a big problem today, but it is a growing problem, which will be a problem in the future. And but it's I think compared to the AI utilization that is used in all sorts of things like crypto, think about that. How just to get virtual tokens, we're having entire groups of power stations blasting CO2 in the air for just getting a bit pattern, right? So that is a bigger concern, I would say, than the few batteries that a camera trap needs to operate for months. However, there is a valid point in what you're making. Like, I personally think of it as Heisenberg's rule for habitats. So, Heisenberg in physics, kind of, if you influence a system by measuring, you will actually change the system. And you can't do both. You can't measure the system and not influence it.
Right.
So you always influence it, and that's why when you measure something, there are limits of even the accuracy that you can get about the system, because you're changing it by measuring it. And that is something in a way that is also happening when you go into a natural habitat. Traditionally, you would walk there with your wellies or whatever into the habitat, and you would disturb it. You would change it. Your presence as an observer, as a human being in there, changes the habitat, and therefore changes what you will measure. It changes the natural behavior of animals. They may even flee from you. They, with camera traps, it's a paper we looked at recently, for example. These animals, these chimps actually are interested in the cameras. So they look at it. They kind of, have a little bit of what is this, right? I see myself in the lens. Is this another, exactly. So there is an interaction. Now, as a side effect, these animals stay longer in front of the areas of the camera. And if you use the time they are observed as a basis for how big the population is, because suddenly your entire measurement is skewed. And I think from this angle, from the angle of disturbance of the habitat itself, it is a massive problem. And it needs to be properly taken into account, because the minimum effect is a bias. The maximum effect is actually a destruction of that environment with technology. So there is a balance to be struck between observing, but observing without interfering. And I think particularly the utilization of remote sensing technology is the right way of going about it. And these are things like this. Now, our Austrian friends produce drones that can actually look through the canopies of forests in the Alps by combining the little moments when you can look through the trees, combining this information whilst the drone is flying over.
That's
you can
amazing.
Look through it in that sense. So there's many ways how you can not interfere and yet get the information out.
Yep.
The energy consumption is something which particularly utilizing visual AI is problematic because they're most data intensive. If you think of a video, how many bits to be processed, every pixel has color data, you have 4K, one frame, and you have 25 frames a second. Now, the amount of information that is processed is massive, much, much bigger than what pure text processing is. And therefore, maybe currently people have limits on free accounts for image generation or video generation because of it, because it's costs the companies more than processing text. But that is actually also an energy cost. It's not only a GPU time cost, it's also an energy cost.
Yeah.
So we need to be careful in balancing this. And I think this is much more a question for the people who in the end utilize it. I mean, I built these things with people all around the world, with our research group here. And we utilize a lot of our Isambard supercomputer here in Bristol to do it. And that takes a lot of energy, but nicely heats also some homes in Bristol. So there is a green footprint to our Isambard computer as well. But my point I want to make here is, in summary, there is a cost for this. And this cost is not zero. I can see it currently as being highly beneficial, much more beneficial than other areas of AI, and I mentioned a few. But in the future, there needs to be a lid on this. And the lid is a cost-benefit analysis of the whole product cycle.
Yep.
And for that, particularly now with an emerging eco-industry that focuses on this, and there are many companies, 25 years ago, we were 5 people in the world doing that. Now there are hundreds of companies around the world that provide these services, NGOs, governments that are interested. So it's a massive growth that this has gone through. And yet, that's at the moment of growth, you need to think about how to balance the cost, energy cost, destructive cost, with the benefit that you gain. And I think in the future we will hit this moment when it's not a clear game anymore. I still think it's a clear game because we don't know much about the natural world at this moment in time.
Yeah, it seems like a lot of upside still in the position we're in. That tees us up really nicely for the next question, actually, which is, I think, it sounds as though you're already in your own practices and how things are being done at Bristol, already kind of going down this very responsible route. But, as a kind of lead in this field, if you could just kind of highlight to us what to you does a responsible practice of using AI within this field of ecology and animal bioinformatics, how does this look in the next kind of 5-10 years to make sure we don't stray off track and go down some of these kind of more destructive or invasive directions? Just as you were saying then, it's gone from teams of within the dozens of people to now a kind of global movement. So are there kind of standards and laws that we kind of need to focus on and try and put in place before the likes of companies maybe like Google or other enormous companies start to kind of get involved, and which
they are involved massively.
Okay.
I mean, this is a AI for Earth.
So Google X, maybe.
Exactly. Yeah. This year we published something together with Meta and Conservation X. Okay. So it's the big companies are doing things also in the not only in the negative sense that we all need to be afraid, but also in the good sense. It's just a big movement forward in terms of AI. Okay, to your question. Your question is, what do we need to take care of really in the next few years to make this AI for good something that can be maintained and stays this way in the subdomain of conservation or animal biometrics generally? To be honest, my biggest worry is access. And maybe it should be the biggest worry for all of us in terms of AI. Because there is a potential for access to AI and compute associated to it being a new class divider. And class divider may be for people, but also for countries, for environments, for whole regions. If you don't have the compute, if you don't have the access to the tools that are developed, you have a disadvantage. And that disadvantage is economic for most things that happen in AI, but in this case, it's ecological. If you don't know what's going on, you can't respond, you can't measure, you can't react, you can't do anything. You don't know. This is like, losing your main senses. And to walk successfully in a city without seeing or hearing is a real challenge. And it's a similar thing in finding the right path through managing ecosystems. So I think access is the main thing. So that is making things open, accessible to people who live in remote places, to people who can't afford utilization of big cloud farms or etc. So that is hard. And that's much more a political appeal I would have here, that it kind of is a playing field that empowers people to utilize the technology rather than not. I can see this as even for, as I said, mainstream AI, a big thing. Productivity will be linked to access. Yeah. And in a way, that's why everybody invests in AI, because people see that this is exactly sitting at this moment where productivity can be tuned. And if you invest in that, this is investing into the first factories of the Industrial Revolution. So that's why people see that, but there are limits to it. The limits are, at some point, things become destructive if you don't offer them. Like, the life of a coal miner in the 50s. In the end, led to lots of strikes and uprisings, and basically a population that wasn't as happy as the wealth that was generated from it could have provided.
Right.
So, and that's you can transfer that to the ecological domain, because biodiversity is wealth. And let me make a point here, because many people would say, okay, what's important to me in my life is, the basics, food, shelter, friends, family, environment, social happiness, all of that. But what we kind of, as a society, have lost track of is the fact, what is the real wealth? Is it the amount of gold you store in your central bank? Or is it something which is actually not at all ever reproducible? And if you think of it, what is that? What is the oldest treasure that this planet has? It's not the gold that's laid down somewhere. Gold is a metal. It is the information that has evolved through evolution of life into everything that lives. It is not replicable. It is, there's Wolfram writes that, computation really, in many ways, doesn't have a shortcut. So you need to go through these cycles of evolution to actually come up with plans that make up life now. You can't short-circuit it. Computation or evolution are not really something you can short-circuit. And the fact that we have, 4 billion some years of that creates a treasure that is really worth protecting, well beyond, wealth of the way that we think about it. And the information in it is not only the core starting point for understanding possibly the answers to, all the questions in medicine and all the questions in future evolution, maybe even the evolution of AI, that protecting the diversity in this biosphere is definitely a worthwhile exercise that is beyond nations and that is beyond individuals, clearly, but where all of us can contribute to. And so from that point of view, what is really the important thing, and what is the important thing to keep AI for good and maintainable in this domain, is to make this clear, that we deal with a treasure for our children and children's children and for next generations and all of that, which is by far, in deep time, the most complex treasure that's been given to us.
Yeah.
There's nothing even comparable in any other domain, in any other area. The complexity of life on Earth is the most complex system that has evolved and that we can't replicate. So it is well worth protecting. And that is well before we talk about that nature is something that can help us emotionally and that we connect to when we smell, the leaves falling in autumn and that a bit of a nice sunset is something which touches us, deeply. And that's well on top of that.
Wow, well said. Yeah, it seems like it should be obvious, right, that that's the most important treasure, the kind of the key thing we should optimize and hold close to us, because even some of these kind of exploratory missions to other planets now are looking for kind of these similar materials elsewhere. But what's the one thing that we know we have on Earth that no matter how far we look out into the observable universe, we can't find anywhere else? So nice. Wow. Very well said.
Yeah, that was so beautiful. And I think because when you went from the gold and how people see that as the treasure, I thought you were, I was thinking much smaller scale, like, well, the nice walk, that is something that makes you feel way better than the gold. But seeing it as this condensed, past of the whole journey of intelligence is very very beautiful as well.
Let me say it's both. But you said this walk, when we walk through nature and feel this connection, we are part of it. Yeah. We can isolate ourselves in cities and sit in front of screens all day. We are still biological beings. We're not beings of chips. So and that connection will always be there with life. Yep. It's possibly the most defining moment that we have is our mortality and our interconnection with the rest of the planet. And everybody feels that. You feel that, before you're born, you feel it as a child, you feel it in old age, you feel it as an animal, as a human, as a plant. You're part of this. And therefore it's accessible to everybody. And it goes to a level which penetrates the last knowledge that science has today, because we don't know, right? In the very, very core, nobody can build a human from scratch to the day. And that shows us that our knowledge there is still, despite the fact that we claim even with AI now, we're getting very close to whatever, simulating the first cell completely. Yeah. Nobody can build a human, by far, from scratch. And that's unless we're there and really... I'm not saying we will never be there, but unless we're there, that we can build an ecosystem. I think there was some Star Trek episode where it's called the Genesis Project, where you actually fertilize our whole planet and bring it into existence. By everything we know, by all standards we know, that takes billions of years. And you can't, it's like, this is the compute you need to get there. Why would you want to destroy something that took so long to be made, right? And you were even part of it. Yeah. So at least you should try your best to get along with it and have a balanced existence with that treasure. Right.
Wow. Well, I hope we figure that out a lot quicker as humans than it has taken to even still try and figure that out with fossil fuels, right? That taken so long to produce that we burn it so quickly.
Maybe a bit of fossil fuels is and was necessary to actually get us in a position to... So there are arguments on both sides, but... eventually, in the long term, the direction is clear, right? I mean, fossil fuels won't be there forever, so whatever we do, we better think of something which is more balanced and sustainable to bring all of us together, right? And by all of us, I always mean the other creatures that we are with, not only us humans.
Yeah, and in terms of saving the planet and keeping these treasures that we have in the biodiversity, could we talk a bit about what happens beyond the AI system and what are some things that policymakers are trying to do, and even for our listeners, like what are some things that maybe they can do?
Participation is always important, and not only from a science point of view, and I'll get there, but also from a pure I care about it perspective, because the things you do are also things you care about. And if people connect with nature on any level, they will start caring more about it and escape the illusion that nature is not important. Because the first thing you do when you have your breakfast, you're actually eating the outcome of a very complex ecosystem that led to whatever your cornflakes in the morning, right? So I think the pure fact, the mere fact of engagement is important. And how do you engage? So that's now how do you practically are part of this? So there is a lot of citizen science projects, and they span by now many domains. So people, for example, when they go on holidays and see animals in a safari or they take snapshots of it and submit it on things like Wild Book, which is something which was created by another person I really think is amazing in this domain, Tanya Berger-Wolf in Ohio, who has built an Immunogenomics Institute there, and they're really at the spearhead also. Or people like Sarah Berry at MIT, they are now opening up a research field connected to the impact that it can make really on the ground at scale. And this is part of our community. This is part of the people who do and who care. So you can, as a citizen scientist, like people do stargazing and report what they see there, or classify things as galaxy or star or whatever. You can, in a similar way, submit your photographs. But you can also lend your own intelligence to, for example, find the chimp and thereby help training systems on, Zooniverse platforms to do that. Now, I would say there is a limit to this, right? I mean, it's a bit of fun to upload your photographs. It's a bit of fun to see nature in your own images and then describe them and be part of this training process. In a similar way, like people are, as I said, stargazing and helping astronomers to kind of classify things. But I think there's more to it, because it is exploring for yourself what is going on in your nearby environment. People have done that with the bird watching community for a long time to report. I think yesterday I've seen on the BBC something about butterflies and that their numbers are going down, and that people can actually report, and they do that. So biodiversity monitoring doesn't have to be a camera trap in the forest. It can be the person on the walk through that forest saying, "Oh, I've just seen a particular woodpecker. I haven't seen them here for a while. Let's report it." And that's a good thing, because then you get a better picture. It's still even that only a starting point, because if you really want to find out about it, go to your environment, to the places where you live, where you go on holiday, and find out about that environment. You can now, because the internet offers you amazing opportunities of studying places and what lives there. And then you often discover, there's actually a nature park where you can go to. You can take your family there. Your kids get connected to these environments. They start to want to know more about it. They might start to learn about it. Places like the Wild Place here in Bristol, where you can actually experience animals. And these links, if you build them, the core outcome is people start to know and to care and to be linked. And it will not only have a benefit for everyone who does it, it has a benefit for the whole community, and eventually it becomes a topic. And that's what we need to do. Make it a topic. If everybody in this world would think that nature is such a treasure that we need to keep close to our hearts, our politicians would care much more about this. Therefore, it is really a bottom-up approach that I think can drive this and has driven this. The very first people who did this type of thing in the 1990s were people like Lex Hebe. It's a person I met in 2008 at the Royal Society. He's a Dutch guy who had a company in Cambridge for a long time. He was one of the first to do individual animal identification in the 90s. Wow. In the 1990s. I mean, in 1990, they published the first paper of doing that. Wow. And he is now really engaged in tiger conservation in India. It's just people who really care and really do. And I think that is not only inspiring to me, but it is a possibility for all of us to take different small steps in your environment in the different ways of some of what I've described, but some you may discover yourself. By just caring about it, asking the question. Yes.
And that's where change comes from. Wow.
That's where change comes from. If many people do nothing, that is possibly the worst enemy of sensible change.
Amazing.
Wow, I love that answer. That's the most bottom-up approach, and I think that's so beautiful.
Well, I mean, it is beautiful, but it is also something where we can all kind of think a little bit, how do I improve my own life? What would I really want to do for that? And yes, it has to do with, your job, your family, your friends. Of course, this is all important, but it also has to do with you feeling good. And you feel better often when you're linked in with something that is also alive. That's the reason why we have pets. That's the reason why we like to see our dog jump in joy. And nature can provide that.
Yep.
It is a source for that. And that as a vehicle to then take that and invest back, give back to nature, because that, well, we're all part of it, is something that also can create joy and can help people overcome their own dark times in their lives. And nature will always stay a light for us because we're part of it. It's like our superorganism. Like we're the one cell in our thumb, or the right thumb, right?
Yeah.
But the superorganism...
If nature's happy, we're happy. Yeah.
Exactly. We'll give back.
Yeah.
And to be in balance there is something I think which many native peoples have treasured along, and which we maybe are losing a little bit, and thinking, like the Sorcerer's Apprentice, that our magic spell book is so good that we have it all under control.
Yeah, and we don't need nature. Yeah.
And maybe we don't.
Brilliant. Well, I don't think we could end on a more inspiring and impactful note than that, and that's kind of all the questions. But wow, that was absolutely fascinating, and thank you so much for your time and sharing your knowledge. And I think as much as we believe this is such an important topic, and one of the truly positive, like you say, applications of AI, one of the ones that we really should be supporting this technology for. I think it's so important to discuss. Not just for the animals, but like you say, for all life on Earth. So it's probably one of the more important episodes we've ever done. So thank you for taking the time.
Thank you for the interview. Thank you for the platform, and thank you for actually doing what you're doing, because I think it is important that people learn about what AI really is, how diverse it is, that it is not 5 big things, but that it is thousands of things that move forward and move us as people and societies forward at once, and to demystify it. So thank you for that. And anyone who's listening, this is such a deep field. It kept me going for 20 years. It is exciting, highly exciting to study it, to learn about it. It's eye-opening. And when you can combine it with something that is also good, then what better to take your mental capacity to and try to make a change. Thanks,
win-win.
guys.
Thank you.
Wow, really enjoyed and so grateful to have Tilo on. And I think the conversation ended on a really quite poetic note, actually, about the treasures of that exist on the planet and what we should prioritize. So
I never really thought of it that way, to be fair. I mean, the whole chat was fascinating. Tilo was great, and I really enjoyed the conversation. But yeah, I think same as you, maybe with recency bias, but that final closing point was really one that stuck with me, because I thought I understood the consequences from doing research about how many species were being lost and the biodiversity was kind of shrinking. But when you put it that way, that evolution has brought us here over billions of years, that is a very, very amazing point we find ourselves in, that's so precarious. And I guess you look elsewhere in the universe, and it's not as if it's abundant. People say life might be abundant. We can't obviously see or detect it right now if it is, but all that we do know for certain is that the biodiversity we have here on Earth is extremely precious.
Yeah, and we should do what we can to keep it. And
exactly.
And again, AI's role in that is really to first understand that we have so much data monitoring the environment and just how vast it is. And if we can do we really want and expect like a human to be able to kind of watch all that footage and all these measurements and be able to condense that into like something that can inform a policy to help protect the environment? And clearly AI's role here as well. AI can scale up. It's got a way bigger set of eyes. It can run on many different devices all at the same time and come to like a condensed conclusion, and reducing that lag between what's happening in the environment and what we think is going on, and really closing that gap is so important to actually fixing the problem before the problem's already kind of over.
Exactly. I think it's super important, like you say, for actually taking action and making sure we mitigate the harm. But I think in addition to that, it just helps for us as humans to be able to understand straight away the impacts we're having and know what decisions and what changes that we make as humans, the effects that they have elsewhere within the planet that we live on. I think with climate change has historically been an example of the inverse of that there's a lot of hypotheticals and saying that, this is where things may go in decades' time, which is obviously incredibly important to think about things that way. We can't just look at the here and now. But perhaps if we know and can detect using AI what our impacts are straight away, maybe that will help us to come together and form consensus around what's going on, and actually then having the voice to make change. As we've seen, the inverse again has been very difficult to do so with climate change. So AI is incredibly helpful here, and I think it's a great example of where AI isn't just ChatGPT and doesn't really harm the environment. And in fact, if we use it ethically and think about using it in the right way, as Tilo was describing, it can have incredible upside, arguably with very little downside. And these are the types of AI applications that we want to be talking more about here on this podcast, and are the truly beneficial applications of AI.
Yeah. So, thank you so much for listening. And hopefully Tilo inspired you to go out in nature and first connect with it if you haven't already, to see what you can do to protect it. Yep. And of course, please reach out to us at contact@artificialeverafter.com.
Yep.
We'd love to engage and hear what you have to say.
Definitely. And if you'd like additional bonus content, extended conversations behind the scenes, you can check that out on our Patreon. We'd very much appreciate your support there, because it keeps the podcast going and ad-free. So thank you so much for listening, and we'll catch you next time.